Welcome to another episode of my reviewer series for civil engineering topics focusing on fluid mechanics problems. For this episode, a vertical cylindrical tank open at the top is used as a buoy. The cylinder has a diameter of 1.10 meters, a height of 2.4 meters, and a weight of 3.825 kilonewtons. Given the problem, what weight of an object must be attached to the bottom of the tank so that the tank is submerged by 1.9 meters in fresh water? What weight of an object, given the unit weight of 110 kilonewtons per cubic meter, must be placed inside the tank so that the tank is submerged by 1.9 meters in fresh water? And what weight of an object, given again the unit weight of 110 kilonewtons per cubic meter, must be placed inside the tank so that the top of the tank is flushed with the water surface? To solve this problem, let's recall muna some basic concepts. Pag ang isang object ay pinatong natin sa kahit anong liquid substance, there is this tendency na pwedeng lumutang yung object na yon unless sobrang bigat ng weight niya. So yung paglutang na nagaganap is yung tinatawag natin na buoyancy. Then yung force naman na nagkakos para sa object na yon para magstay on place na lumulutang is yung tinatawag nating buoyant force. Looking at its system pag nasa state of equilibrium, masasabi natin na yung buoyant force is just equal to the weight of the object na nakapatong sa liquid substance. With that, alam natin na in order to determine our buoyant force, the value for this is just the unit weight of the liquid that the object is put into, then multiplied by the volume of the object that is submerged beneath the liquid surface. Or simply, unit weight ng liquid na pinaglulutangan ng object times dun sa volume ng nakalubog. Given this set of equations, we can now actually proceed to solving our questions. For our first one, tinatanong sa atin kung ano yung supposed weight ng object na naka-attach sa cylindrical tank if we are to maintain the tank's submerged height of 1.9 meters. To determine that, we just have to solve this using our static equilibrium equation, the W equals Pf. So for the value of our total weight, syempre including self-weight ng cylinder na 3.825 kilonewtons, add lang natin yung unknown weight ng object, which we will denote as W sub O. As for the value of our buoyant force, alam natin na ang unit weight ng fresh water is just 9.81 kilonewtons per cubic meter. But for the volume submerged, dito sa problem na to, hindi lang dapat yung tank yung i-consider natin, kundi pati na rin yung object kasi exposed din yung volume nito sa fresh water natin. So for the volume of the tank muna, given tayo ng diameter na 1.10 meters. Therefore, we can say na yung radius nito is 0.55. Tapos ang height naman ng supposed submerged volume ng tank is, as stated sa problem, dapat 1.9 meters. Given those values, we can solve for the volume of the submerged cylinder by multiplying pi times radius squared to its length of 1.9 meters. Solving for the buoyant force involving the cylinder lang muna, we will get a value of 17.73. Tapos for the volume of the object naman, wala tayong given na dimensions para dito. So at first, mukhang medyo mahirap to ma-determine. Pero kung mapapansin niyo mabuti, meron tayong given na unit weight ng object. And as long as talagang na-familiarize na natin yung sarili natin sa idea na yung unit weight is just equal to weight over volume, pwede natin paglaruan lang yung equation. And pwede natin ma-express yung volume in terms of weight divided by unit weight. Therefore, ang buoyant force due to object would be unit weight of water na 9.81 times unknown weight ng object divided by its own unit weight of 110 kilonewtons per cubic meter. having one variable unknown, pwede natin to i-equate sa ating scientific calculator, and after performing shift solve, madedetermine na natin yung supposed na weight ng object, which is 15.248 kilonewtons, given the condition na positioned yung object sa ilalim ng cylindrical tank. For our second question naman, ang given naman natin na condition is to determine the weight if yung object naman natin is nasa loob. Pero yung submerged height is same pa rin naman na 1.9 meters pa rin below the water surface. Ang approach naman natin dito is actually similar lang sa kanina. The only difference is, kung yung kanina considered na may influence yung added object sa buoyant force, this time, wala na. Kasi yung volume ng object is not submerged sa liquid mismo, but rather, nasa loob na siya ng volume ng cylindrical tank natin. So, ang total weight natin is same as kanina na 3.825 plus W sub O lang. Tas yung buoyant force naman natin, ang ko-consider lang na submerged volume is yung sa value ng cylindrical tank. Therefore, yung buoyant force natin would just be equal to 17.713 kilonewtons. Equating the value of total weight and buoyant force, makukuha na natin agad yung value ng unknown weight, which is 13.888 kilonewtons. Proceeding to our last question. Ito naman is same lang din sa second question natin. Ang difference naman this time is instead na 1.9 meters lang, yung buong height na yung submerged exactly just below the water surface. So technically, copy lang natin yung solution natin sa second problem, but palitan natin yung value na 1.9 ng 2.4 meters, since yun yung given na full height ng cylinder natin. Solving for the unknown weight of the object, given the submerged condition, we will get the value of 18.549 kilonewtons. And as simple as that, this situation is finally solved.